Algebra 1, Lesson 42, Solving Percent Problems. Our new concepts. A percent is a ratio that compares a number to 100. For example, 50% is the ratio 50 per 100%. There are three components that form a percent statement. The whole is the total amount. The percent is a rate that quantifies an amount measured with respect to the whole. And the percentage is a number that represents a part or percent of that whole. For example, in this example, 25% of 20 is 5. 25% of 20, the whole, is 5. You could also read this as a multiplication problem. 25% of means multiplied. So if you took 25% times 20, it would equal 5. Well, in order to do this mathematically, a lot of times we take a percentage and we convert it into a decimal. If two of the components are known, the third component can be determined, but in order to do that, when we're calculating with percentages, to find the percentage of any number, we take it and turn it into a decimal, and when it says of, that just simply means we multiply by that decimal. In example 1, it says, using this in an equation to find a percentage. It says, what number is 25% of 50? Basically, it's asking us to say 25% times 50. Well, to do that, we change the percent to a decimal by moving that decimal point 2 places to the left. So 25% becomes 0.25. Then you multiply by 50. 0.25 times 50 is 12.5. So that number that they're looking for, what number? 12.5 is 25% of 50. Letter B says, what number is 125% of 64? Percentages can be greater than 100. It doesn't mean that they're changed, but when we're changing them to a decimal, it does. Notice on 25%, I moved that decimal 2 places to the left. When it's a number that is greater than 100%, it still only moves 2 places to the left. So 125 needs to be changed to a decimal. We move that 2 places to the left, it becomes 1.25. That's 125%. And you're going to say, again, of 64 means multiply by 64. 1.25 times 64 equals 80. 80 is 125% of 64. So let's say you had a math test. There were 64 questions. But one of those questions offered you extra credit. 64 out of 64 would give you 100% if you got 100% correct on that test. If you maybe got that extra credit, maybe you got an 80 out of 64, therefore you got 125%. So something can be greater than 100% in that case. 80 is larger than 64, so the percentage is bigger if you were to write that number as a fraction. A percent statement can be set up as a proportion as well. One ratio compares the part of a quantity to the whole quantity. The other ratio is the percent rate written in the form of a ratio. So in this example, the part is written in the numerator, the whole is written in the denominator. This becomes the percent rate. So for example, 10% of 50 is 5, can be written as a proportion. 5 out of 50 is equal to 10 out of 100. How would you go about converting that? Well, just look at the ratio here. 5 times 2 is 10, 50 times 2 is 100. So there's a direct proportion or ratio between these two. Example 2, using a proportion. What number is 125% of 48? Well, we set up the proportion to find the percentage. We don't know the number in comparison to 48, but we do know that 125 is compared to 100 as our 125%. Anything written over 100 can be the fraction form of a percentage, so 125 over 100 is 125%. Our missing variable is here. You would cross multiply and divide. C times 100, 48 times 125. 48 times 125 is actually 6,000. It's equal to 100. We divide by 100 then on both sides. We'd cancel both zeros and you would get 60. 60 over 48 is 125% of 60 is 125% of 48, which we found out from that calculation. You could also do it in terms of multiplication. You take 1.25 times 48, you would get 60. So you could learn it from either the very first method, wait, we did that something similar right here, and the second method with a proportion. Now there's two ways to solve those type of percent problems. In letter B, 15 is what percent of 45? So here we don't know the percentage, so we can write that as the missing variable in this numerator proportion over 100, because anything written over 100 is a percent in fraction form. We'd say 15 divided by 45 equals x over 100, cross multiply, 45 times x, 15 times 100. 15 times 100 is 1,500. We divide by 45 on both sides, and you'd get x equals 33.3. So 15 is 33% of 45. Example 3 is our application calculating wages. Anna receives $1,153.84 in gross earnings every 2 weeks. However, 28.07% of the gross earning is removed from taxes and other deductions. Using an equation to determine the net pay. So in this example, you're going to take the $1,153.84 that's in her check and take away 28%. So you need to find what that 28% is and then subtract that overall. Here's how they did it in the solution. 28.07, they turned that into a decimal by moving the decimal 2 places to the left. 0.2807 is 28% in decimal form. You multiply that by the total or by the whole, because it's of that as multiplied as a percentage, you get $323.88 needs to be deducted. That's what she's being taxed each time that her overall income comes in. Then you take $1,153.84, subtract $323.88 to get a total net pay of $820.96. Seems unfair, but that's the way in which taxes work, in which those taxes go to the different types of amenities that our country affords us to have. So we take that income, we reduce it by the income tax, and this is what you actually get paid. It'd be nice to just get this and not have to worry about taxes, but taxes pay for a lot of those things that we don't think about. Example 4, finances. Dominic earns $9.25 an hour working part-time. The circle graph shows how he divides his earnings. This month, Dominic has worked a total of 54 hours. Find the amount of Dominic's earnings that he will put into savings this month. So each time he's making money, he says, I'm going to do this thing called tithing, which you may have heard about in the Old Testament. It means I'm going to give the first 10% of my earnings back to the church, or in this case, to charity. Then he's going to take 40% of those earnings and he's going to put that into savings, and the other 50% is his budget, what he has to work with in terms of his spending. So we would take the amount of money that he's making each month and then divide it by the percentages that he has allocated here for these earnings. So we get $9.25. We'd multiply that by 54 hours. 9.25 times 54, he made $499.50, almost $500 this month. So making that much money, you're going to then turn each of those percentages into a dollar amount, or you're going to divide this up in those percentages. What they use here is the proportion for each of those. What amount out of $499.50, the total, is 40% that's going to go into a savings? What amount is going to go into the 10% portion and the 50% portion? So you're basically repeating this problem 3 different times. Here you cross multiply and divide, and you find that $199.80 goes into his savings. You could also take 0.4 as 40% turns into a decimal, multiply that by $4.99 and get the same answer. Here's how they solved it, writing a proportion. So he put $190 in savings. You say 0.1 times $499.50 to say how much percentage is going into charity. You can say 0.5 times $499.50, see how much he's going into his personal spending. The question asked us how much is he putting into his savings each month, so that's why they only solved this portion of the problem. If you'd like to, for extra practice, your example problems, it's giving you the different types of percent problems, which you'd write those out as multiplication or in the proportion form to show that you got that level of mastery. Otherwise, you're going to begin working on your practice problems. They are the circled problems from your practice problem sheet for lesson 42. God's blessings.